Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to the technical session 60. I am Meghna Mathur, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Ashish Patel. Welcome, sir. Sir is an associate professor at Parul Institute of Pharmacy, Parul University, Gujarat, India, with a robust background in organic, medicinal, and analytical chemistry. His research focuses on developing anti-cancer, anti-diabetic, and anti-Alzheimer's agents. Dr. Patel has authored 69 publications in prominent journals, co-authored multiple books, chapters, and is a patent holder. Sir, welcome.
Thank
Now,
you, Meghna.
I would like to start with the papers. Our first paper for this event is the author is Nikita C. with the paper title 5G Physical Layer Analysis.
Good afternoon, ma'am. Good afternoon, ma'am. Good afternoon, everyone. I'm Nikita Chavan. Today, I'll be presenting our Project 5G Physical Layer Analysis. Anyone can hear me? Can you hear me, guys?
Yes, we can hear you.
Sorry, sir. Our presentation covers the problem statements, objectives, the literature survey methodology, pre-coding analysis, and finally the results and the conclusion. The problem we address is analyzing the 5G physical layer, especially the physical downlink shade channel. We are identifying the key parameters that are required to configure the physical downlink shade channel in 5G and are
Ma'am,
using.
you're not audible.
Am I not audible, ma'am? Hello?
No, you are audible. No problem.
Okay.
You can continue.
We are identifying the key parameters that are required to configure the PDSCH in 5G NR using the MATLAB's 5G toolbox, and we are trying to stimulate the performance under different signal to noise ratio conditions. The main goal here is to understand how the performance changes as the conditions vary. As we know, 5G physical layer, it is the foundation of 5G networks and it is responsible for encoding, modulation, transmission and reception of data over the air. And here the channels PDSH physical downlink shade channel, it is used for downlink user data, and PD physical uplink shade channel, it handles the uplink data. And here are the importance of the physical layer analysis. As we can see, it is used to understand the system performance under various propagation conditions and resource allocation and interference management. And we used to develop new solutions for high demand using cases like autonomous vehicles and for anything. So Basically, physical layer analysis is essential for reliable high-speed communication. And here are some of the objectives that we are trying to implement in our project. That is to identify key configuration parameters in 5G NR using the 5G toolbox, and building a simulation model for PDSH transmission, and analyzing the performance under different SNR values, measure metrics like BER, BLER, and throughput, and visualize results and optimize configurations. And here are some of the literature survey that we have taken from the previous works related to 5G systems, massive MIMO, and precoding techniques. Researchers have shown that linear precoding techniques provide a good balance between the performance and complexity, especially in 5G downlinked systems. These are the few papers that we have used and understand about the 5G networks and the methodology. This shows overall methodology of our system. The process starts with downlink shade channel and then followed by the pre-coding and then PDCH mapping, and there's a cyclic prefix orthogonal frequency modulation, and then the transmission through the channel, then channel estimation takes place, and finally the decoding at the receiver. This flow closely represents a real 5G downlink transmission chain. Coming to the precoding. Precoding is a signal processing technique which is applied at the transmitter to reduce the interference and improve the signal quality. Precoding techniques, they are mainly divided into two types, that is linear precoding and non-linear precoding. And in our analysis, we are mainly focusing on the linear precoding, and that too on maximum ratio transmission, zero forcing, regularized zero forcing. Okay, this block diagram shows the precoding process. Input data is processed using a precoding matrix, then it is modulated and transmitted through the channel, and finally demodulated at the receiver to obtain the output data. Some of the merits of linear precoding techniques are the zero forcing. It performs well at very high signal to noise ratio. And coming to regularized zero forcing, it provides better sum rate performance, and maximum ratio transmission. It performs better at low SNR with low complexity. Regularized zero forcing. It improves upon zero forcing by adding a regularized factor, which helps reduce the noise amplification. It balances the interference suppression and noise resistance, making it suitable for 5G systems. In short, we can say that it acts like a very smart volume control which reduces the interference without boosting noise too much. Coming to zero forcing, it completely eliminates the inter-user's interference by inverting the channel matrix. It requires accurate channel information and has high computational complexity. Maximum ratio transmission. It focuses on maximizing the received signal strength, and it has a very low complexity, but it does not actively cancel interference. So its performance, it mainly depends on the system conditions. These are the few formulas that we use to calculate the ZF, RZF, and MRF. This chart shows the analysis that we observed that RZF, it outperforms the ZF and RZF in terms of sum rate, especially under varying SNR conditions. In varying SNR conditions, we have the RZF, which shows the better performance compared to the ZF and MRT. And here it is a chart of bit error rate versus the signal noise ratio. As SNR increases, BR decreases for all the techniques, but RZF achieves a better balance between the error performance and efficiency. Even here, while comparing the bit error rate and the signal noise ratio, RZF achieves a better balance between the error performance and the efficiency. This is the overall comparisons that we have seen. Overall, precoding significantly improves the downlink shade channel performance by enhancing the signal quality, reducing the interference, and improving the throughput. Among all the techniques, RZF emerges as the most versatile, offering balanced performance, good energy efficiency, and manageable complexity. Coming to the conclusion, our project successfully analyzed the 5G physical downlink shared channel using the MATLAB simulations. We studied different pre-coding techniques and found that regularized zero forcing provides the better overall performance for 5G downlink systems. And these are the few references that we have used for our study, including the IEEE papers and some 5G literature. Thank you for your time and attention. I'll be happy to answer your questions.
Okay, am I audible? Hello.
Yes, sir. Yes, sir.
Okay, nice work,
Thank you.
Nikita. Just one in your slide presentation, you mentioned the literature, and after I think 2022, you wrote mention. Is there any work done in the 5G networking?
Sorry, sir.
So you have shown the literature in your presentation.
Yes, sir.
Okay, in
Yes.
that I have seen the year of publication and whatever reputed work. After 2022, is there any literature? Like,
Sir, yes, sir. There are papers, sir, which have been, there are service papers which we haven't considered, sir, because
okay,
while we were studying this, we found these papers for easier for us and better understanding compared to the other papers in recent days, sir.
okay,
So we haven't taken a look
mm,
at the recent papers, sir.
okay. Can you tell me? I hope you know the nowadays 6G revolution is also
Yes, sir.
undergoing and
Yes, sir.
okay. So can you tell me which physical layer features of the 5G we can consider is the most relevant and crucial when we are doing for any 6G revolution,
6G
implementation?
for 6G revolutions, which layer,
Yes.
sir?
Because when we are upgrading from 4G to 5G, 5G to
Yeah,
6G, so
6G.
there is some important critical features
Yes, sir.
that is
URL,
very
LC, EMBB, and
uh,
MMTC, sir. Yeah.
so okay. So how can you correlate if anyone want to take your concept and take the some key features for the 6G revolution?
So, our paper can help for 6G features too, sir. Like, coming to RZF, it is one of the physical layer which can avoid the complete interference and of the noise, sir. And ultra low latency coming to URLLC or this network slicing layers, sir, that can be helpful for the 6G. Coming, you asked me a question, right, sir? EMBB, sir.
Mm, okay.
Enhanced mobile
And
broadband, maybe that would help, sir. I'm not
how
sure.
it is fundamentally different from LTE wave design?
Sorry, sir?
You develop the 5G layer, okay?
Yes,
So I
sir.
hope you know the LTE wave design and numerological parameter used when we are doing the any generation.
Huh. Yes, sir.
So how can we differentiate that way if you know?
Sorry, sir. I don't have much knowledge about
Okay,
this.
okay, okay, no problem. Thank you, but it is nice work you've done till, and it is I think ongoing.
Okay. Thank you, sir. Thank you so much, sir.
Thank you. Now moving on to our next presenter, Chaitra BT, and the paper title is A Frequency Domain Perspective on Nonlinear System Identification, Methods, Models, and Modern Advances.
Hello, good afternoon, everyone. Is my screen visible?
Yes.
Yeah, thank you. So, yeah, I'm Chaitra from MIT Manipal, Karnataka. So, firstly, thank you so much for giving this opportunity to present in front of you all. And our paper title is a frequency domain perspective on nonlinear system identification. It says methods, models, and modern advance. And these below are the co-authors of this paper. And these are the table of the contents which I'm going to present for the next few minutes. And coming to the abstract of this paper, nonlinear system identification is an important and challenging task in control engineering because most practical system exhibits nonlinear behavior. Traditionally, frequency domain method were originally developed for linear systems and cannot be directly applied to nonlinear dynamics. So this review discusses advanced frequency domain techniques such as frequency swipe methods and variational inference and students T distribution based models and co-evolutionary algorithms for identifying nonlinear systems. So it also highlights hybrid approaches that combine signal processing and machine learning to provide modeling accuracy and robustness to noise and adaptability. Based on recent studies and cases examples, the paper outlooks current trends, limitations, and open research gaps. So next, we are moving to the introduction of this paper. So basically, this article focuses on nonlinear system identification using frequency domain methods, an important topic in control engineering and signal processing. So the system identification is a process of building a mathematical model from input to output data to understand and simulate dynamic systems. Many real-world systems exhibit nonlinear behavior, which makes their identification more challenging than linear systems. So most traditional identification methods were developed for linear systems and often fail to capture nonlinear dynamics accurately. So, the frequency domain techniques provides an alternate approach by analyzing system behavior across different frequencies, so offering better insight into complex dynamics. So, this review summarized existence research on frequency domain methods for nonlinear system identification. So, next, coming to the system identification. So basically, system identification is a process of determining a system model to understand its dynamics. So it obtains a model explains the cause-effect relationship between input and output. So there are mainly three types of system identification. One is notion of a system identification. Then we have a linear and non-linear system identification. Then we have parametric and non-parametric identification. Let us see in brief of these three. So basically, first one, notion of a system identification. It helps it applies across many industrial and research sectors. So among them, few are like control system designs and fault detection and RFID applications and rotating equipments analysis, where control system design is used for designing controllers for systems such as heat exchangers, and fault detection is also used in identifying faults in the nonlinear processes, and RFID uh, applications are used for various paper substrates and can be operated in harsh environment also. And in rotating equipment analysis, there is frequency shift based system identification helps in studying the dynamics of rotating machines, and some of these are the advanced modeling techniques. And then coming to the linear and non-linear system identification, as we all know, there is only a two modeling categories, that is linear and non-linear. So in linear modeling, or simple but may not accurately capture complex system behavior. Non-linear models provides better representativeness since real systems are inherently non-linear. The selection between linear and nonlinear models involves a trade-off between accuracy and complexity. So, in many cases, assuming a purely linear model is unrealistic due to non-linear phenomena such as friction. And TLP systems have attracted significant research interest in identification, analysis, and control. When coming to the parametric and non-parametric identification, so in parametric identification, it assumes a specific mathematical model structure, whereas in non-parametric identification, it does not assume any predefined mathematical structure. And then uh, coming to the system identification procedure for non-linear system, so here we have a problem formulation. So basically, problem formulation refers to a clearly defining the system, the available input and output data, and the object of estimating a model that best represents the real system behavior. So here in system identification, our main goal is to develop a model that behaves as closely as possible to the real physical system. So this become challenging when the system is non-linear, especially when it is represented in a state space form. So in this approach, the system behaves is identified using measured input and output data collected over time. The input represents when we apply to the system, and the output represents how the system responds. So based on this data, we estimate unknown model parameters so that the model output matches the real system output as closely as possible. And the system is described using two equations as mentioned in this slide. So first equation will be x of k plus 1 is equal to f of k of xk, uk, and vk and theta. So one of these explains state of the system changes over time. So this means the next state of the system depends on the current state, the input applied, disturbance, and some unknown parameters that we need to identify. In the second equation is y of k is equals to h of k of x of k, u of k, e of k, and theta, where this explains how the output is generated. And the output depends on the current state, the input, and the measurement noise, and the same model parameters. So using measured input and output data, these unknown parameters are estimated so that the model output closely matches the real system output. So then we have a different system identification techniques. So let us see different kinds of approaches which we are explained here. Firstly, I will go through frequency swipe system identification approach. So here the uh, the frequency swipe system identification approach is mainly used for rotating or spinning the machinery, where traditional NARX modules fails due to disturbance. In this method, the system is excited using a signal whose frequency is gradually varied, and the response is analyzed across different frequencies. This allows accurate modeling of both linear and nonlinear dynamics of a system. The method is robust and suitable for industrial applications. Through it requires higher data and computational resources. The next we have variation inference six base approach. So here it is used to estimate the hidden states and parameter of nonlinear systems. The main idea is that directly calculating the exact behavior of the system is too difficult. So six approximates it with simpler disturbance. So this approximation is done by minimizing a difference called KL divergence between the true system behavior and the simpler one. So next
Sorry
we have
to interrupt, Chaitra. This is a gentle reminder that you have 1 to 2 minutes to conclude your presentation.
yeah, thank you. So then we have a student's distribution model. So here it is used heavy trailer students T distribution to model process and measurements noise. And it is used to practical smoothing with the T distribution for robust identification. Then we have a frequency domain subspace identification method. So it is designed for stable linear time periodic systems with one input and one output. So and it is exponentially modulated periodic excitation signals. So then we have a simulation result from this. Um, by using a maglev systems was using this because its non-linear and unstable nature makes it an excellent benchmark for a system identification. So input and output data was generated using a broadband acceptance and inject and with a noise to create a realistic experimental conditions. So we got one plot using the MATLAB. So here we have a x-axis and y-axis, where x-axis is represents the frequency in hertz, and y-axis is a residential PSD log scale. Then we have a curve also here, where so this curve is called the actual PSD, which says that the true power spectral density of the system output. Then we have a linear ARX residuals for the linear ARX module. Then we have MLP residuals and RBP residuals. Then coming to the conclusion, so the review highlights variety of frequency domain techniques for nonlinear system identification, comparing parametric and non-parametric method and their strengths. So modern advancement including data-driven, then evolutionary and variational inference-based techniques. Then the major trend is rise to hybrid approaches that blend physical state knowledge, then using magnetic leviation system simulation demonstrate how different nonlinear identification method performs, illustrating the practical value of these techniques. So, and the future work should be on integrated signal processing and control theory and AI to create adaptive, scalable, and generalizable identification framework for advanced applications such as robotics, aerospace, and energy systems. And these are the reference papers which we are used in this review paper. Thank you.
Okay, Chetra, am I audible?
Yes, sir.
Okay, so you you've done the non-linear type frequency domain model. Okay,
Yes.
so can you tell me the any one example that is a success compared to time domain frequency model, which is non-linear type?
Uh, I can tell. I can give an example for a rotating motor, sir. Like
Okay,
instead of applying a constant input, we slowly
okay,
change the input frequency and observe how the motor responds. From this
okay,
response, we can identify nonlinear effects like vibration and stiffness changes that normal models cannot capture.
okay, okay, good. Uh, which machine learning model you integrated with your generation of frequency domain non-linear model? Is it a neural network or any other
Yes, sir, it is neural network.
neural network? Okay. So, is there any key challenge also when you are generating your non-linear type model when you are using the neural network, or you directly selected the neural network only?
Um,
Any graphical base have you tried only, or only you have tried this normal, no hybrid method in machine learning?
it is directly selected ones.
Okay, okay, okay. And what about the suppose we are having some experimental data practically? So have we estimated through this frequency domain non-linear type compared to time domain? Any
Uh,
idea?
mm,
Suppose we have any experimental data. practically we are having some data, and we are not talking
Okay.
about I'm not talking about the data set. Okay. So how can we apply the frequency domain nonlinear model in that practice?
Sir, we need to analyze PSD coherence value like
Okay.
FRF analysis, sir.
Okay. Okay. Thank you. Nice
Okay.
presentation.
Thank you. Thank you so much.
Thank you. Now moving further, we have our next presenter, Durga Nandini. The title of their paper is An XAI-based approach for privacy preservation of maritime vessel detection.
Good afternoon, everyone. Hope I am audible. Um, Give me a second. I am sharing my screen. Um, I hope the screen is visible. So, yeah, first, thank you for giving us this opportunity to present our paper before you all. I am the Ganandini Chalmal Sethi, and today I will be presenting our work title, An XI-based approach for privacy preservation of maritime vessel detection. This work is a collaborative effort by Dr. C.H. Rupa, uh, B.H.N. Chandana, and myself. The focus of this research is on combining accurate vessel detection, data security, and explainability for real-time maritime surveillance. So, coming to the abstract of our project, maritime vessel detection from aerial images plays a critical role in coastal surveillance, port monitoring, and national security. Traditional object detection techniques like RCNN and SPM offer reasonable accuracy, but they are very computationally expensive um, and very slow, so they are unsuitable for real-time applications. Although earlier versions of YOLO, which is You Only Look Once, improved speed, they suffered from localization issues, especially in crowded maritime scenes. To overcome these limitations, our proposed system uses YOLO V11, which integrates transformer-based attention and partial self-attention modules. In addition, we strengthen the entire system with SHA-256 hashing for tamper-proof detection records and explainable AI techniques to enhance transparency and trust. The motivation for these works come from real-world cybersecurity threats in the maritime domain. In April 2024, a major cyber attack disrupted global vessel tracking systems, altered AI signal, and caused huge financial losses. This incident highlighted that accurate detection alone is not enough. Surveillance systems must also ensure data integrity and trustworthiness. So, our work directly addresses these challenges by integrating security and explainability into the detection pipeline. The scope of the work is limited to maritime surveillance using aerial images. So the system focuses on detecting a single class, namely the ships. Despite this single class limitation, um, we ensured that the system is doing a great job in for real-time detection and tamper-proof logging and transparent decision making. So making it a strong prototype for critical surveillance applications. The key contributions of our work are leveraging YOLO V11 for accurate real-time detection of maritime vessels, incorporating SHA-256 cryptographic hashing for privacy and data integrity, integrating explainable AI methods to provide visual explanations of the predictions that are done by the YOLO V11 model. Coming to the literature review, we went through several recent works, and these works have explored YOLO-based vessel detection, including YOLO V8 and YOLO V11 variants. However, most existing approaches focus only on detection accuracy. So our work differentiates itself by combining detection, security, and explainability into a single end-to-end system, which is essential for high-stake maritime environments. Coming to the methodology, this is the proposed architecture diagram. As you can see, there are three modules, which is vessel detection using YOLO v11, and privacy preservation using SHA-256 hashing, and explainable AI integration. Um, yeah, the data set we used here was collected from Kaggle, and it contains 621 images of ships, and these are annotated using Pascal VOC format. So to train the YOLO model on this data set, we had to convert it, we had to pre-process it and prepare it for the YOLO model, and we converted into text format, which is compatible for YOLO training. This preparation is done by using algorithm 1, which is displayed here. And after converting, we split the entire data set into training and testing sets. So coming to module 1, which is vessel detection, YOLO v11 processes the input images and outputs bounding boxes, class labels, and confidence scores. Um, Non-maximum suppression, NMS, is applied to remove redundant detections, and performance is evaluated using intersection over union, which is also known as IOU. The transformer-based backbone and partial self-attention modules in YOLO v11 significantly improve detection accuracy, especially in complex maritime scenarios. So figure 2 here represents the internal architecture of YOLO v11, which essentially contains three important parts, the backbone, neck, and the head. Coming to module 2, which is the privacy preservation. So after the detections, after the YOLO v11 detections, the entire metadata, which includes the bounding box coordinates, the confidence scores, and the class, these are serialized and these are passed into SHA-256 algorithm. It generates a unique 256-bit hash value for each detection results. So if there is a very minute change in the detection or in the image, it can we can know that there is a change because the hash value will be different for even a minute change. So this makes the records tamper-proof and suitable for forensic verification and secure logging. And the next module, which is explainable AI integration, we use the technique DCLOSE, which is Detection Central Local Surrogate Explainer, to analyze how the detection confidence changes when different parts of the image are considered. To do this, we perturb the image, which is like dividing the image into several blocks or several smaller pixels, and then masking some of the pixels or some of the blocks, and then feeding the masked picture to the YOLO v11 model, which we have trained earlier. And by doing this, um, we can get to know which part of the image is affecting the detection more when compared to others. After that, um, we generated heat maps that highlighted regions that highlight the regions of the image most influential in vessel detection. So these visual explanation allows operators to understand why the model made a particular decision, and we can also it is also useful to improve the model accuracy, detection accuracy, and it also increases trust and usability in real world deployments. So this is the algorithm. This is the entire algorithm of the proposed work, which essentially contains four different steps, which I have explained till now. Coming to the implementations and results. So the implementation demonstrates accurate vessel detection using YOLO v11. As you can see here, figure 3 represents the YOLO V11 detection of a image feeded into it. It also provides the count of how many ships present in the image. And after the YOLO detection in figure 3, this is then feeded in, the metadata is serialized and feeded into SHA-256 algorithm, which generates a hash value. Figure 4 shown here is an image overlaid with that 256 hash value. And figure 5 gives a heat map of the YOLO detection. Here the regions in red shows that those parts are more important and more influential for the detection than the parts in the colors like yellow, green, and blue. Coming to the performance analysis, the performance was evaluated using confusion matrix, and it shows that the model does a pretty great job at detecting the boats with very few true positives and false negative. Sorry, very few false negatives. Um, we also we also calculated the performance metrics like precision recall, F1 score, and MAP of the model, which are around 0.94, 0.92 to 0.94. And this is the graphical representation of MAP, which is mean accuracy precision over 50 epochs of the training. So finally, coming to the conclusion, this work presents a secure, explainable, and efficient framework for maritime vessel detection. The future work essentially includes expanding the dataset for large-scale benchmarking, optimizing the model for edge and UAV deployment, and improving XAI methods for more intuitive operator interaction. Um, so these are some of the references we used, which are also included in our paper. Thank you for your attention. I would be happy to take any questions.
Uh, am I audible? Durga Nandini.
Yes,
Hello.
yes, sir. I can hear you.
Okay. 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 Uh, Actually, your approach which you develop it is one of the best, as per my opinion. We need this type of approaches. Uh, just one concern is that regarding the scalability, because we know the whatever approaching you are proposing, okay. If we compare that approach for real time compared to large sea region, so how it is scalable? Is there any hurdle, or we can do the scalable also that?
Yes, sir. So the core detection module we used is YOLO V11, which is
Okay.
which is less complex when compared to traditional models like SVM and all. So we can include this in real world scenarios. As for scalability, we need something which is really fast, which can work on less expensive
Okay.
computation and which will work very fast. So YOLO V11 checks all these boxes. So it is scalable to use in real world, like
Okay.
in live CCTV feeds and UAVs. And also, our future work also includes doing this for videos as well instead of just images. So,
Okay. What about the border security and small port? Is it visible that in that surveillance area?
sorry, sir, can you please repeat that?
Can your framework, it can be considered another surveillance area, like it can generate compatibility with the border security and small port. So only in the sea region we can consider.
Uh, yeah, we primarily consider the sea regions.
Okay.
Uh, we need to
Okay.
think more about the border security and all.
Okay. And what about the quantification and measurement? Suppose any privacy leakage in the system. So is there a necessary step in your mind in your leakage in privacy quantification measurement? Your backup maybe some necessary step in your mind. If any privacy leakage in your system, then if you know then, huh? Otherwise if you are planning to that or if so no problem
We will look into it, sir. At the moment,
because
sorry.
uh, because because this type of approach is when suppose any problem is arise, we should have some backup. This is our backup. So any leakage system may occur in future. We don't know. So we can easily resolve that matter. Okay.
Okay.
Okay. Otherwise, nice approach. And the whichever
Thank you, sir.
algorithm you use, that is also nice. Okay. Continue. Thank you.
Thank you, sir.
Thank you. Moving further, we have our next author, Shivapriya, with the paper title Answering Multi-Hop Queries in LLMs by Utilizing the Strong Product of Knowledge Graphs.
Good afternoon, all. Myself Shivapriya, and today I'll be presenting on the paper entitled Answering Multi-Hop Queries in LLMs by Utilizing the Strong Product of Knowledge Graphs. So, knowledge graphs are considered to be a powerful way of representing knowledge, and it simplifies complex structured data or complex and interconnected data into graphs by representing them in terms of nodes and edges. So, basically, if there are some entities like the graph nodes represent the entities or objects, and their relationships are represented using edges. So based on the relationships, the knowledge graphs can be both directed as well as undirected. So one of the challenges of building a knowledge graph is that it requires a huge manual labor, expert knowledge, and multiple complex steps for the construction. So an example of the knowledge graph on the company Meta and its associated companies is presented here. So in the given example, the nodes are representing the persons and the company associated with Meta, and the edges, specifically directed edges in this case, are indicating the directions, indicating their relationships between one another. So in this work, the primary objective is to incorporate the idea of knowledge graphs, and which actually is beneficial to both knowledge graphs as well as LLMs. So the one of the drawback which we have told earlier of knowledge graph is to come up with expert knowledge. So the introduction of LLMs has helped in knowledge graph data retrieval easier. And when it comes to LLMs, the combination of knowledge graph with LLM have improved the interpretability and efficiency of AI systems. The LLM or large language models are actually completely based on huge text sources such as Wikipedia. So what they do is when a query is put by a user, they go back and collect all the available text from such sources and break it down into and consolidate into different parts in order to answer to the user query. So there are different shortcomings or drawbacks of such retrieval, because there are chances when the data can be outdated or the text sources can be outdated, and then the LLM may present an inaccurate response to the user query. So apart from this, when a large or huge or complex questions are asked to a LLM, it may break it down into smaller part and search across multiple such text sources, and there are chances where the LLMs may cook up facts or fabricate facts and provide to the user. So this is called hallucination, and this takes up almost a lot time, and also cook up facts. So in order to overcome such shortcomings, we are trying to incorporate the idea of knowledge graphs into LLM, which helps in eliminating the chances of hallucination, since they are a better way of representing data. So in this methodology, we'll first present you how the knowledge graphs are constructed and how this is fed into the LLMs. So the first step is to consider a text source or the input text, which is then made into subtext known as chunks. And then the subject, predicate, object triples are identified, followed by standardization where the extra characters or unnecessary characters are eliminated. And this is followed by inferring, where the graph structure is obtained, and finally the visualization where the entire knowledge graph is obtained. So this entire pipeline is then fed to the LLM in order to answer queries in an easier manner. So the first step is text chunking. So once the input text is identified, this input text can be of larger size. So the initial step is to divide the entire text into sub chunks or subtexts. So once the chunks are obtained, each of the from each chunks, the subject, predicate, object triples are extracted. So the subject and object acts as entities, or they are represented by nodes, whereas the predicate acts as the edge, which indicates the relationship between the two nodes. So once such triples are identified, the process like case folding, trimming white space, and removing punctuations are performed. So this normalization process is performed in order to eliminate any extra data or unwanted characters from the graph. So apart from this, there are chances where similar terms such as, for example, here we have birthday and date of birth. Both these are of the same meaning. So in such cases where similar terms are observed to be found, we combine or merge such terms into a single node. So this process actually improves the downstream usability by decreasing noise, and also boosts the consistency of the graph. So the final process before the visualization is enriching of the graph. So in this graph, the entire nodes, relationships, everything is presented in an interactive manner or as an interactive graph. And apart from that, if any of the relationships are missed, the straightforward logical rules such as transitivity is performed in order to obtain such relationships. And the final step is visualization. So in visualization, what we do is we just beautify the graph. So there may be various nodes which all belong to a specific subtopic. So such graphs are all merged, or all are made into a cluster and assigned a particular color. And if there are any nodes which has a larger relationship, that is, there are more relationship from other nodes to this particular node, then this node is represented as a larger node with a larger node size. So and then the representation of relationship between the entities. So when representing the relationship between any two entities, we may use both dashed lines as well as solid lines, where the solid lines represent that there is a direct relationship between the entities, and whereas the dashed lines represent there is an inferred relationship between the entities. So once the knowledge graph is constructed, our next idea or the second step of this proposed method is that we structure it in terms of a Cartesian product, the strong product of knowledge graph. And this is a mathematical operation which we use here in order to obtain a lesser traversal time. So the strong product of knowledge graphs will be considering, since the knowledge graph is kind of a star graph, what we do is we choose a path graph and form the strong product of the graph. So such a structure helps us in easier traversal between nodes, and thereby reducing the response time. So we have provided the structural comparison between the usual knowledge graph and the strong knowledge graph. So apart from the structural comparison, it was required to show how the traversal time was varying between both the graphs. So what we did is we have asked three queries with respect to both graphs, that is the usual knowledge graph as well as the structured strong knowledge graph. So we have asked three queries and obtained the traversal time. And the queries we have asked were who are the Nobel laureates. So in both the graphs, we have considered the knowledge graph on the Nobel laureates, and we have asked the queries starting with who are the Nobel laureates, what were the fields of the Nobel laureates, and which year did they win the Nobel Prize. So when each of the three queries were asked for the both the graphs separately, the traversal time was obtained and it was tabulated as given here. Even though the time difference may not seem to be of much difference in this example, as we tried with multiple other graphs having larger order or higher order graphs, it was observed that the time difference kept on increasing and it was in favor of the strong kg, and this time difference was less for the strong kg, and thereby showing that it provides a quicker response. So from the work, we have identified that combining the concept of knowledge graph, specifically the structuring of the knowledge graph in terms of strong product, simplifies answering multi-hop queries. And the traversal time was significantly reduced, and hence the response time for the queries also reduces. So apart from that, we were able to minimize the hallucinations, which was usual in the LLMs, and this can be further extended to several other domains, and specifically in metric development, chunk size optimization. These are the references used in the paper. Thank you all for your time and patience. I'm open to any questions and suggestions.
Okay, nice concept. Shiva Priya, am I audible?
Yes, sir.
Um, First, can your model handle any noisy or incompatible or incomplete knowledge graph, or only normal you can do?
So when we are we're structuring this in terms of knowledge graph, we were having some extra edges, like since it is a strong product, it has multiple edges compared to the usual graph. So to eliminate such edges, we had to add something like there will be an edge showing no relation. So
Okay.
that is one drawback which we came across. But
Mm,
if we could add one more like step and eliminate such edges, then it would be better.
then your equation is good. Okay. Uh, can your method, this method, which can be adapted for any cross-domain or multi-model listening task, or in normal adaptable?
Oh, sir, we haven't went through that.
Okay, you are not apply. Okay, okay. So what about the when you are developing this LLM based reasoning multi-type. So even you observe, because uh, we are working with one model also, we observe the hallucination issue.
Yes, sir.
So is there any issue you observe? So how to mitigate that issue?
Sir, this hallucination, to minimize the hallucination, we are using knowledge graph, sir, because when we are strictly minimizing all the text, then such hallucinations are observed to be are also observed to be minimized.
Okay, okay. And which data set do you use for this your main centric data set?
So there was a data set available in GitHub, which was on all Nobel laureates.
Okay, okay, use that data set.
Yes, sir.
Okay,
Already available data sets.
okay, okay, good. Nice work. So that is done from my side. Good
Thank
luck.
you.
Thank you. Moving further. Our next presenter is Vaishnavi Sagar. The title of their paper is Cybersecurity Risk Assessment in Medical IoT Networks.
I am audible. Hello.
Yes, you are audible.
Yes.
Good afternoon to the respected panel member. I am Vaishnavi, and today I have a privilege of presenting behalf of my research team, which includes the Umme Barida, Shubham Jaiswal, and Shivcharan Reddy, under the guidance of Professor Siddha Kesh and Professor V. Mareshwari. This research was conducted at AMC Engineering College. We are here to present our research paper titled with the Cybersecurity Risk Assessment in Medical IoT networks. Let's start with the introduction. Uh, the rise in the medical Internet of Things introduces a significant cyber threat, risking a sensitive patient data and device integrity. The traditional systems lack of integrated frameworks to counter the diverse and any anomaly attacks, but our paper integrates the robust cryptographic methods, which is SHA-256, with AI-based anomaly detection, which we are using isolation forest. This framework ensures the data confidentiality, integrity, authentication, building a secure and trustworthy MIT ecosystems. The main objectives of our paper is to secure the IoT protocols for transmitting the real-time health data from the medical devices and the sensors, ensuring the data confidentiality, integrity, authentication through the TLS encryption and with the hashing SHA-256. We are also integrating the AI-based anomaly detection where we are using isolation forest to identify any suspicious activity and mitigate the risk of cyber attacks in a medical IoT devices. To provide the real-time monitoring dashboard, we are using Streamlit dashboard for the visualization of a data for the professionals and visualize the alerts and detect the anomalies. These are the main features of our paper, which consists of a layer architecture ensuring the secure data flow in medical IoT networks with the compliance of guidance through the cybersecurity risk assessment. We are giving the real-time health data monitoring. We only mainly focusing on the data integrity and confidentiality, and also it consists of a machine learning-based intrusion detection system with early identification, and we are using the lightweight design optimized for the resource constrained IoT medical devices. We have come up with a solution where we are securing the IoT health data. We use the framework to securely transmit the health data from IoT devices, ensuring the data is protected during the communication. And also we are using the AI-based anomaly detection. Here we integrate the AI models automatically, which detect the suspicious activity or cyber threats in a real-time data. And we are providing the dashboard which allows the real-time monitoring that allows the healthcare professionals to monitor and to alert and to respond the threats effectively. These are the literature survey we did. The paper titled with the Evaluating Medical IoT Device Security Using NIST IR Expectations. This paper evaluate the MIT device security framework using the NIST guidelines. But it happens only conceptual, but lacks in a experimental validation in real MIT networks. The next paper is towards the design and development of security assessment framework for the Internet of Medical Things. It mainly introduces a framework for the security of MIT networks on the focusing on some of the vulnerabilities. But it is limited to theoretical framework, but it lacks in a testing and the practical healthcare settings. The third paper is a lightweight blockchain and fog-enabled secure remote patient monitoring system. It combines the blockchain and the fog computing for the secure patient monitoring. High resource consumption is needed, maybe not feasible for the lightweight MIT devices. So it is cost. Its cost is more. The four, The fourth paper is Survey of Machine Learning Based Intrusion Detection Methods for the Internet of Medical Things. By this, this paper consists of a ML based intrusion detection approach for the medical IoT devices, which lacks in real world dataset validation and scalability and testing. We are using the HMAC SHA-256. What it means? We utilize the HMAC, which is a hash-based message authentication code, which combines the SHA-256 algorithm. This will generate the unique cryptographic signature for every single data packet sent by the medical sensor. What's the role of SHA-256 in our system? The role of this is for the data integrity. This mechanism ensures that the data received from the cloud is exactly what was sent by the device. If the hacker alerts even one bit of the patient heart rate data during the transmission, the hash signature changes, the system immediately rejects the packet. The main use to defense against the tampering, we are using SHA-256. Unlike simple encryption, which only hides the data. But
Sorry
SHA-256.
to interrupt. A gentle reminder that you have 1 to 2 minutes to conclude your paper.
Okay, fine. Which proves the authenticity. It verifies the message originated from the trusted ESP32 device has not been tampered with the man-in-the-middle attacker. Or why we are using the SHA-256? It is a standard and secure cryptographic hash function which provides the perfect balance between the high security and the lightweight performance which is needed for our microcontroller, which we are using ESP32. Then we are also using the isolation forest, which is a model explicitly isolates the outliers rather than the mapping the normal patterns, making the detection faster. Why we are using this? For the MIT network efficiency, which is ideal for the real-time streams. It efficiently pinpoints and identifies the few and different anomalous patterns with low computation power. And it has a one feature called dual thread detection. Simultaneously, it helps for the uh, identifying the patterns and any suspicious behavior, and it also gives the smart alerts, automatically categorize the risk into warning and critical alerts by triggering the notifications via SMS mail for the immediate actions needed for the security teams. What are the requirements for our system? For hardware requirements, we are using heart rate sensor and temperature sensor, microcontroller and blood pressure sensor. For the software, we are using the programming language Python and operating system. For coding, we are using VS Code, Streamlit for the dashboard, and platform IO for the sensor reading data from integrated with the VS Code. And this is our flow chart. Here we can see that IoT medical sensors, we are using the heart rate sensor, body temperature sensor, and blood pressure sensors. All they are connected to the ESP32. Then the data from the ESP32 is sent into the real-time database with the SHA-256 securing the transmission between them. And after this, we are integrate the cloud with the isolation forest model. If any anomaly detected, means it will any if anomaly act means they triggers the alert, and if no means it will be stored as a normal data. We can see it all together in the Streamlit dashboard, and we can visualize the and live risks and vitals and all. Here we are using the methodology. We are using the 5 modules. First module is hardware setup. We begin with the connecting the ESP32 with the medical sensors on the breadboard. The ESP32 was programmed to read the sensors value and which are heart rate, temperature, blood pressure. And second module we are using is secure data transmission. Once the data is collected, it is encrypted and transmitted to the TLS. We also used SHA-256 to ensure that the data is not modified during the transmission. Third module we are using data processing and storage. On the back end, the server decrypts the data and check its integrity. Stored it securely in the cloud database. Such we are using the cloud Firebase. This steps ensures the scalability and secure handling of sensitive health information. Fourth module we are using is AI-based anomaly detection. We apply the machine learning model to detect the unusual activity. We are using the isolation forest, and which identifies the abnormal sensor reading, which may indicate either a medical emergency or a cyber threat. The fourth is we are using the module real-time visualization. The processed data and the detected anomalies are displayed on the Streamlit-based dashboard, which provides the healthcare professionals with the real-time alerts and actions to be taken against data. These on all the graphs, tables, analysis, simulations we have done. This one is a component overview. Here we are using temperature sensor, and this is heart rate sensor, and this is blood pressure sensor, all connected to breadboard with along with the LCD. These all connected to ESP32. That all the real-time data is collected in a ESP32. Here we can see in the output. Here we can see the all the data which is live readings from the collected from the sensors. And this is the alert frequency dashboard we got from the real-time data by using Matplotlib. We plotted this graph. Here we see that the normal status. If there are 120 events are there, these are the normal. The green color indicates the normal, but the orange color wants the alert system, which is event type of 50, and the 35 is the critical alert. It is in the risk it's showing, and this one is the risk score. It scales between 0 to 1. It is a histogram plot. It show along with the ranges from 0.2 to 0.4. It's showing the risk score is low, and it's between
I'm sorry
8
to
to 1.
interrupt, Vaishnavi. This is again a gentle reminder that the time limit is been up. Kindly please conclude your paper.
Okay, 2 minutes. And
Go to your
8
conclusion slide. Go to your
okay.
conclusion summary because we are in another 5 presentation.
Finally, we conclude that the we prepared the framework that transits the vulnerable patient data into the protected way by real-time asset, and we are using the hybrid defense barrier by using the HMAC SHA-26 with the active AI anomaly detection, using the isolation forest with the low powered hardware and scalable intelligence. We are using the cloud, which is a Google Firebase, which is scalable. Final output we just display it on a dashboard. Thank you, sir.
Okay, Vaishnavi,
Yes, sir.
hello. When you are giving the presentation, you need to address key point. Okay, no need any evaluator or panelists don't want the detailing of the presentation. Okay,
Okay,
so
sir.
next time key point we need to include. Measure we need to focus on the what objective is plan and methodology discussion and then conclusion. Okay, anyway, uh, I want to ask you a question. Now, first, how your MIoT network which you okay, developed for cybersecurity risk assessment is distinguished from the traditional IT and general IoT system? Is there any key features specifically you included which can be, highly accurate?
So can you repeat the questions? It's not clear.
How distinguish your cyber security risk assessment in MIoT network which you developed compared to traditional IT service and general IoT system?
Okay, like we are using real-time data, which is we are using the ESP32 board, which is a very low powered and it is resource limited only. We are not using that much resource. It's resource limited. We are consuming the power and also we are providing the scalability to store the data, real-time data in cloud.
Then what
That's the
about
difference.
okay. Then when you're implementing your this continuous risk assessment, when we will do, you have done or you will do in future for large scale MIoT networks, is there any key major challenge you observe or you will observe in future?
Yes, sir. In for the larger scalability, we have to like integrate with the hospital. This our system we
Okay.
have to integrate with the hospital. It's very deep challenging with large real-time data and all. We have to use the standard ML models for the intrusion detection system.
Okay. Thank you. Nice presentation.
Thank you.
Moving further, we have our next presentation from the author Vaibhav Pratap Singh, and the title of their paper is Embedded Validation of Deployed Blockchain Architectures with Cryptanalysis Enhanced Smart Contracts on Ethereum. Okay, moving further, we have our next presentation from the author Dhruvit with their paper title Financial Portfolio Optimization Using Deep Reinforcement Learning.
Hello everyone. Can you hear me?
Yes, you're audible.
Yeah, thank you. I'm going to be sharing my screen now. Hello everyone. So I'm going to be presenting to you financial portfolio optimization using deep reinforcement learning. So when we think about finance portfolios, it basically comes under bonds, stocks, and other assets. So our research is mainly upon stocks. And when you think about stocks, the modern portfolio theory states that rather than investing on one stock, it's better to invest on multiple stocks. It diversifies the risks and gains you higher returns. But the stock price dynamics are mainly influenced by various factors like macroeconomic factors, firm performance, geopolitical events such as election of president, wars, hedge funds behavior, and other investors. So the traditional statistical models like ARIMA, mean variance models, they fail to capture these dynamic relationships. But with the upcoming of newer technologies and deep learning models like recurrent architectures and NLP techniques, they have been able to easily grab better features, and they are better at feature extraction and temporal dependencies such as RNN and LSTM are able to capture temporal dependencies in financial time series and any other time series of data, and NLP can easily capture sentiment data from text. text data. And then when we so my study proposes an integrated investment framework where I combine deep learning, where basically we use transformers, sentiment analysis, and reinforcement learning to achieve better forecasting and risk-aware portfolio optimization. So when we think about the literature review, the recent research done in this area is mainly like uh, the recent studies have demonstrated growing reliance in artificial intelligence and deep learning techniques to address nonlinear and uncertain nature of financial markets. Machine learning and NLP-based approaches have been widely applied in portfolio optimization and risk management. There have been introduced various robot and fuzzy optimization techniques so that they can handle transaction costs, uncertainty in the market, liquidity constraints, and estimation errors. And we also, as I said, there are various time series models such as RNN, LSTM, which were able to understand the temporal dependencies as the future data was stored in the next neural network. And then deep reinforcement learning has emerged as a powerful framework because of its framework, wherein it will quickly understand the rewards in the previous time framework, and based on that it's going to make the strategy for the action in the next time frame. So the objectives are: we develop a reinforcement learning based trading framework which integrates structured market indicators. We're going to have the traditional OHCLV data, open, high, low, close volume data. We are going to add other indicators to it, and we are going to have a dual path feature extraction wherein we use transformers because of its inspiration from the LLMs, as it can capture more features compared to the RNN and LSTMs. And then we are gonna capture the sentiment patterns of the uh, people in the live market using the existing models such as Finbird. And together we are gonna integrate it into a PPO based trading agent which simulates the market environment, our research methodology. So when we think about the methodology we have used, we are gonna collect the historical and market data and technical indicators mainly from the Alpaca API, and we are gonna extract the news and the financial news and text data through Yahoo Finance API. And the feature extraction is mainly done through a simple transformer that we have designed, where temporal patterns in stock prices are learned. And we are going to use the existing reinforcement learning based trading agent, which is implemented in the simulated market, mainly proximal policy optimization. We use it compared to the existing TD3 because of its stable policy learning. And then we test it against the benchmarks such as buy and hold mean variance models using standard performance metrics like cumulative returns, Sharpe ratio, and maximum drawdown. So our transformer architecture mainly consists of 6 layers. The first layer is the input observation layer, where we have a fixed sliding window. The window is going to consist of fixed days, fixed sliding days of 60-day windows, and we are going to preserve the temporal structures across recent days. And the linear projection layer is going to convert that 1 into n dimensional layer into a n into n dimensional layer by multiplying it with a n into n dimensional matrix according to the matrix rules of multiplication, so that we get a high dimensionality matrix with a better features. And then we are going to encode give it positional encoding based on the time frame which day occurs previously, is going to give a previous time positional embedding. And then we are going to encode it using a transformer encoder, which basically encodes all the layers using multi-head self-attention and feed forward networks to capture long trend temporal frequencies in the entire time window. And then for that entire encoder, we are going to apply temporal mean pooling, which basically converts that high dimensional vector to a low dimensional matrix, uh, extracting only the mean features out of it. And the final linear output layer is gonna generate the compact feature of high dimensional 1D vector. So this is our model. So we have a PPO agent which is gonna take a random action based on that is buy, sell, or hold, and based on the random action, the environment is the state is gonna take the random action is sent to the environment. The environment is going to calculate the next state and the reward for the next state, and the PPO agent is going to take the action again for the next state. So this is our trading algorithm. Our trading algorithm consists of a policy pi theta, which is a probability distribution of say buy, hold, and sell, and the value network V phi, which is the value that is the reward of the current state, and the transformer encoder F trans, which is gonna calculate the function value of the features. So for each episode, we take a random window from the training set, and for each step, we construct the features, that is the its price, the technicals, and the sentiments, and we are going to encode that state using a transformer encoder, and we are going to take a sample action based on the probability distribution. And after taking up the random action based on the probability distribution, we are going to execute the action, observe the portfolio return, the cost, and the drawdowns, and for that entire training window, and then we are going to compute the reward for it, and then we are going to, after calculating the reward, we are going to store the transition state, and after calculating the stand, we are going to end the for loop, and then we are going to update the probability distribution and the reward to the mean reward of that PPO objective, and then we are going this is going to calculate for n episodes as the user inputs, and then we are going to end the loop. So we have performed testing based on for the following portfolio strategies, including mean variance optimization and equal weighted portfolios. Um, and for these portfolios, we use risk adjusted platforms using metrics such as Sharpe ratio for return consistency and downward risk, and we also portfolio is analyzed through maximum drawdowns to evaluate how robust it is compared to the adverse market conditions. And we also calculate the volatility and understand the stability of the market. So these are our results. So our portfolio has given us higher returns compared to the traditional buy and hold and the Markowitz portfolio theory. Um, so it has been evaluated from the January 2023 to December 2024 using backtesting results, and we have accumulated a return of like twice the actual wealth, 111%, outperforming buy and hold and Markowitz strategies. So as you can see, for the entire annual year, it was able to almost be same as the cumulative return was almost the same as the other models, but in the end of the year, it was able to capture some temporal dependencies and features, and it increased its cumulative returns. However, the drawdown, when we come to the drawdown, maximum drawdown, our model had the highest drawdown. This was a limitation because it because of the higher because of the reward ratio, the higher end was on the drawdown, and because of it, the model was performed less compared to the other models in the drawdown ratio percentage. I mean, but despite the higher drawdown, it was able to recover faster and give a much more better returns compared to the other models. And when we think about the Sharpe ratio, it had a better Sharpe ratio compared to the other models. So in conclusion, this study presents an integrated reinforcement learning based investment framework that combines the structured market indicators with sentiment signals. We have a dual path feature extraction wherein we also not only understand temporal price dependencies, but we also try to analyze the sentiments of the people using the classical we use a Finbert machine learning, I mean Finbert NL natural language model, and we also have calculated the empirical results through the PPO agent. However, the model experiences slightly higher drawdowns. So in the final conclusion, what I'm going to say is that the model is, however, is still a black box one, making it a bit more unstable, just like the other deep learning models like CNN, RNN, and LSTM. So more research is required for understanding its interpretation. So as to exactly how the model works. Yeah, these are my references. Thank you.
Am I audible, Rohit?
Yes, sir.
Uh, nice presentation, and I think you apply deep reinforcement learning. Okay,
Yes, sir.
so you try only this tool algorithm, no CNN, RNN you have used. Okay.
Yes, sir. CNN, RNN, I thought like the
Mm.
last time I tried it on a project, it had less appealing results. So I thought that if I apply like transformers, because when it comes to LLMs, transformers are far better than RNN and LSTM because and CNN because they capture temporal dependencies more. Like when you think about the words, like in a
Mm.
sentence, it can predict the next word much more better than the RNN and LSTM. So I thought I was inspired by the transformers in the LLMs, so I thought of
Yeah,
using
it
transformers.
is good. That's why I asked. I think you know that's better, more than enough. Now one, I think you also observe when you're done practically in your tool. How you address the any data leakage or bias which you observe during the training, data
Yes, sir, because
segmentation?
it's a black box model. That's
Yes.
the research which is being done, like interpretation. Because it's a black box model, so like sudden change in the hypermeters can change the overall results. Like sometimes the model will perform way worse than the other models. Sometimes it performs way better than the other models. It depends on the hyperparameters and like how the
And
model is being trained with hyperparameters.
okay, what about the transaction cost and liquidity constraint? There are so many, after a post-market is settlement and all going on. So is there any effect to your that performance and learning during the development model?
Yeah, but like the model can be trained using like the liquidity of the market, but yeah, the data was not available for liquidity and the transaction cost. I had the data, but the volume was available, but the liquidity was not available for training basically.
Okay, 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 okay. No problem. Nice work you are doing and continue. Good luck.
Thank you, sir.
Moving further, we have our next presentation. The authors are Shefali Sonavane, and the title of their paper is Performance Analysis of Multi-Class Classification, a case study of oral cancer detection and growth estimation.
Hello, am I audible?
Well, yes, ma'am, you are.
Okay. Hello, good evening to all of you. Myself, Dr. Sharvari Solapure. Instead of Shefali Madam, I am giving presentation of our paper. She is busy a little bit in the important meeting. Just check my screen is visible to you.
Yes, ma'am, it is.
It is visible. The paper ID is 341. The title of the paper is Performance Analysis of Multi-Class. Just stop my video, just the range issue. Performance Analysis of Multi-Class Classification. A case study of oral cancer detection and growth estimation. Author names are Dr. Shefali Sonawne, Dr. Sharvari Solapure, and another one medical professional. She is Dr. Megha Nimay. We all are from Maharashtra, Sangli. I am presenting this paper in the 10th International Conference, which is held at Jaipur in the online one. So let me just give the introduction of this particular topic so that you can understand. We are actually working with the one problem statement related to the oral cancer. So early detection of oral cancer will give a number of solutions for the doctor. Doctor means a BDS or dental. Okay. So the introduction related to this one, oral cancer is globally significant and early detection is very critical. What we have already communicated with so many medical professionals is very critical. And they want some better solutions by using their small mobiles or some image devices. And we have already working with this particular statement. AI and ML is improving the diagnostic capability, whatever our study have given us the idea, and the research papers also which we have referred. Study develops this paper study develops a binary and multi-class classifier. We have used tissue and non-tissue images. So these are the two pictures which are there in my presentation. This image, which we normally called as a photo, which is called as in medical term a non-tissue image, and these are the two images which are there below. Those are called as a tissue images. So these tissue images are something like as in the medical world, it is called as a pathological images, or they somehow they are from the certified from the lab. These are called as tissue images, and these are our normal non-tissue. When we discuss related to this problem statement, doctor wants the solution for this non-tissue images. But most of the research is there with the tissue images also. So we are working with the both right now and for the binary classification. So this is a simple introduction of the particular topic. Then which data set we have used? There are two different data sets we use, binary data set and multi-class data set. So binary data set where we have used the tissue images and non-tissue images. 48% of the cancerous and 51% around is non-cancerous. The non-tissue also 66 cancerous and 33% non-cancerous. Then the multi-class data distribution. Our main work in this paper is particularly for the multi-class because we already worked with the binary data set. We got a good results also. And now in this paper, we are mainly focusing with the multi-class. So that multi-class data distribution is in the 5 class. We got this again from the particular author, and the data set is divided into 5 different classes. These are the names of those the stages of their cancers. These are all medical terms, and with respect to that, the data is divided. For our engineering point of view, the data is divided 24.32% in the first category, first class, 20.76 around 76 images for the this one. So like this is called as a multi-class data set, and we use this in our particular work, in this particular paper work. Then these are the objectives. We have built a binary and multi-class models. We compared the KNN, CNN, decision tree, random forest, and support vector machine algorithm performance. We use a pre-processing and different color models for the better performance. After that, we got some good results, and then we got to know that we can make a hybrid model also. So we created a hybrid model, a CNN and SVM, CNN plus SVM model. And another one feature which we have added in this particular model, we are predicting the time growth of a cancer tissue using another one mathematical model. So this is what exactly the objective of the particular work. Then this is the methodology. The right hand side is actually a simple activity flow diagram where we are giving a data set. After that, we are using a pre-processing. Along with that pre-processing, some historical data set and some data cycle references are used. Then the fifth stage is the data training, where we are finding the problems related to the overfitting and like that. Then the sixth step is for the data validation. Then the eighth one is choosing a suitable disease estimation. So estimation and prediction model is at the eighth stage. Then for that we have used the medical professionals, so many domain experts from that medical professional, and then we are generating some reports and graph like that. So this is what exactly the activity which we are doing. For that we are using a different types of data, say different professional experts, and work is still going on. So in this particular work, we have used, as I just mentioned, the tissue and non-tissue data for the binary classification, and another one which is called as a multi-class for the five clusters. Here we have done the pre-processing of a complete data, a cleaning, overfitting, and like that. And then we use whatever the different algorithms which I just mentioned based on the feature categories which are prominent in the particular disk cancer application, cancer detection application. We achieve the model stability for the pre-processing of input data. Then checking the effect of a pre-processing on the input image data. Here we are doing a pre-processing or some of the concepts related to only image data, only images of that particular patient. Then extend this work, okay, to compare the performance with respect to the multi-class data set and using all other machine learning algorithms. Then takes the implementation with to another concept is the hybrid model and estimating the cancer growth using the statistical approach which I just mentioned, and demonstrate this cancer growth rate using a region growing algorithm. So doctor wants that either there is a doctor would like to know that whether there is a cancer. If there is a cancer, what is the pre-cancer stage or maybe what exactly the severity. So for that, this region growing is very important. So that also we have identified. Then some pre-processing techniques which I just mentioned, which we are using it with the image data set, because those are improving the accuracy. We have already worked with that, so we have used the normalization and all that in our previous work. So here we use the various color models, and we have done the RGB enhancement, brightness, contrast, and color balance techniques are used, and this type of images are used. Some fluorescent transformation, noise removing, resizing, segmentation. So this purpose is what to improve the feature clarity and the model stability. So for that, these all are used. So the picture shows the non-tissue images in various color models. So whatever the first RGB image, it's a non-tissue image. And for that, the different color models are the grayscale image, fluorescent image, and same environment. Fluorescent image is mostly used because it is giving a better clarity related to that particular image. Now the results are something like this. Binary classification accuracy we compared with that data set which we have discussed in the second and third slide, and we got the result, very good results for the CNN. So that's why we continued with this CNN. Here we have used the RGB tissue and enhanced RGB tissue images, and RGB non-tissue also, and enhanced RGB non-tissue. So tissue and non-tissue both are used, they are used in the binary classification. Now, after that, the five class classification, so whichever the data set we used a decision tree, random forest, and support vector machines for that. So we haven't used KNN as the CNN is performing very better, so that's why we have taken now after that a support vector machine for the multi-classification because SVM is very good for the multi-classification. So the results are something like that. We use the F1 score. So F1 score is very important to understand the classification algorithm performance. So if we just see the graph, we got a very good results again for the SVM. We got ideal results for this third class. If there are 1, 2, 3, 4, 5 classes. So and just because of the images are very minimum, 34 images are there, that's why we got an ideal result. Somehow, otherwise the results are spread like that, and SVM is performing better than the decision tree and random forest. Then the features of the CNN and features of the SVM both are combined in this hybrid model. So CNN is used for the feature expression with respect to this cancer detection domain. SVM is mainly used for the multi-classification, and both of them together gives us a higher accuracy or better generalization on the small or imperfect data set. This is a small data set. We didn't get a very huge data set. We get a huge data set of a tissue type, but non-tissue type data is very minimum, which is available freely on the net. Then the graph is showing with respect to the five class classification, and this model CNN plus SVM hybrid model is performing very good. Again here RGB, grayscale, fluorescent, and CMY, these color models are used. As the color models are playing a very important role, So we decided to use that pre-processing in this particular work. The other pre-processing tools also we are using simultaneously in our work. So if you just see that fluorescent is giving a good accuracy around 95.75% for the hybrid model. Then the next concept which we have already implemented in this particular work is the region growing segmentation. So see that these are the images. So in the first one, the cancer image is shown in the sub diagram A. Then the cancer region is segmented, area is marked. And after that, the growth is checked after 2 months in the C, after 4 months, after 6 months, and after 8 months. So this is actually required, and this is mainly for the time parameter. It is required for the doctor that if the normal dentist just observes some of the he got that okay, there is a maybe the chances of a cancer. So with respect to that, that image can be just predicted. You can predict that maybe after 4 months or 8 months, what will be the severity. That is what exactly the expectation from the medical professional. So we worked related to that, and we have extracted the region boundaries. We use the seed points over there, and the growth prediction is done by growth prediction model and algorithm, and which helps in accurate lesion area detection. And this is mainly for the growth analysis, and we are using some predictions over there for the size. Okay. In short, we have work related to binary class data, multi-class data, and whatever our result shows a very good performance. So the conclusion is that improved accuracy with the pre-processing, because we have, I just mentioned that there are so many pre-processing tools we are using, and in this paper only we focus with the color model. A hybrid approach of a CNN and SVM is most effective, and this model or this logic is very useful for the early diagnostic, because that is the need from the medical practitioner, early diagnostic and the clinical decision making. If we compare these three together, CNN alone is actually a deep feature extraction is very good, accuracy is also very high for that. SVM alone, if you use it for the manual features, and accuracy is moderate, and a small data set classifier, it is SVM, but SVM is mainly for the multi-classification. So that's why we added these together in the hybrid. So CNN is used for the feature selection, SVM is for the classification, and we got the good accuracy for that. And this is based for the medical imaging and imbalanced data, because we are not getting a balanced data, as it is again mainly related to the non-tissue images. Okay. So these are again different, so many references I have just added right from our work, and open for the question.
Am I audible?
Yes, sir.
Uh, Nice work, and this is the actual needed work because of the cancer issue in the entire world. And actually, my team is also working on some carcinogenic AI-based work. So little bit, it is correlate also.
Okay.
The one serious concern when we are doing this type of, cancer-based work, data set. So can you tell me the size of data set which you use?
Right now, which we have used is a moderate one, sir. I can show you in the presentation also that I have added all the details.
So is it from the pathologist you collected or some metro hospital?
No, sir. It's a mix of data. We collected from pathology lab also. That we got it, as I just mentioned, is the
Okay.
tissue type of data. Some researcher who is there from the UK university, uh,
Okay.
name is Vishal, something like that. And
Okay.
he had given us that, but that is only tissue type of data. And the medical practitioner to whom we discussed, they want a non-tissue, because they want just a maybe mobile tab and some machines, and they would take up one picture and they would like to analyze that maybe after 3 months, and how will be the condition of that particular patient,
Okay.
and then they will go for the further whatever their treatment.
Okay. Yes, because we are also facing this issue. That's why I'm asking.
That I know that, sir. That is a
Uh,
big issue. Data set is a
okay.
big issue. We got it
Uh-huh.
from our that medical practitioner. She is dentist actually. She is my friend. So she had given
Okay.
us a
One
lot
more.
of data.
Have you tried for GNN?
No, sir, we haven't tried it. We
It's
mainly
my
got
suggestion.
okay.
can try because we are getting very good tremendous result in GNN.
Okay, sir. We'll
And
try that. We'll
image
try
processing, if you are trying, then you can try because almost we set up our model. And
Okay.
in GNN, we are getting very good result. And we are trying to tie up with the another state hospital also now. Gujarat, we have done. Our state is
Gujarat.
done.
Okay.
You can try with, if you want any help related to this matter, you can contact. I can try my best to correlate some data set.
Okay. Okay.
So otherwise, nice work and just take huge data and accuracy will be good definitely. And many clinician are interested. When Metro Hospital are
Yes, sir. Sir,
interested for this type of AI work.
yes, yes, sir. I'm also interested to work because this is a real issue actually, and we need to
Yes, yes,
solve this one. Because everywhere we are saying AI and we are not giving a solution to them.
yes, yes.
Sir, can you give me your
Otherwise,
contact number or afterwards I can take it from you
I will share
to
in
Madam
the chat
Regina,
box.
Madam?
Okay, no
Okay.
problem.
Okay. Chat box you
Okay,
can share, sir.
uh,
Thank you
no
very
problem.
much.
Thank
And we
you.
are having a good results for the tissue images, sir. The tissue image is very huge data. It's maybe around 1 lakh above that tissue. Somebody have worked with
Okay.
the PhD. Somebody have worked for the PhD work, PhD thesis, and that huge
Mm.
data is available to with us. So if you want that, I
Okay.
can share with you that with the author
Nice,
permission.
nice, man.
Okay.
Definitely.
Sir.
Thank you.
Thank you. Thank you very much.
Thank you, ma'am.
Thank you.
Moving further, our next author is Lipsita Jaina, and the paper title is Sentiment Analyzer for Marketing Using Natural Language Processing.
Hello everyone. Am I audible?
Yes, you are.
Is my screen visible?
Yes.
Okay. So hello everyone. This is Lipsita Jaina. Today I'll be presenting our paper titled Sentiment Analyzer for Marketing using Natural Language Processing. This work primarily focuses on leveraging the NLP techniques to automatically analyze the customer opinions and extract meaningful sentiments insight for marketing decision making. Coming to the next slide, this would be my presentation outline, which would be starting with the introduction and motivation behind this work, the related work and research gap, problem statement, the proposed system, architecture diagram, algorithm, the dataset description, implementation, evaluation and result, conclusion, and future work. Coming to the next slide. So what is sentiment analysis? Sentiment analysis is a process of extracting and classifying the opinions from text.
Sorry to interrupt. Ma'am, Sharvari, ma'am, your screen is still sharing. Can you please stop sharing the screen? Thank you, ma'am. Lipsita, can you please share your screen again and then start?
Okay, just is it visible now?
Yes, it is visible. Thank you.
So let's start from the starting, or
You may continue.
so sentiment analysis is basically a process of extracting and classifying the opinions from textual data to determine the emotional polarity, be it positive, negative, or neutral. And NLP is a field of artificial intelligence that focuses on enabling the computer to understand and interpret and generate human language in a meaningful way. This is our data set. We have taken the Amazon video game data set and we will be talking about this data set in the upcoming slides.
So the primary motivation behind this work is today most of the customer express their opinions freely through the online reviews, social medias, and feedback platform. For a business, these reviews are extremely valuable because they reflect the real customer experience. But however, when the volume of the feedback becomes very large, it is really impossible to deal with or analyze it manually. So more importantly, this manual analysis are slow, subjective, and cannot provide timely insight for decision making. This creates a strong need for an automated system that can quickly understand the customer opinion and summarize them in a meaningful way. Sentiment analysis address this challenge by automatically identifying whether the customer feedback is positive, negative, or neutral. And with the help of the natural language processing, business can transform the unstructured textual data to actionable insights. These are some of the related works that we have gone through. Some of the approaches are listed down as honeycomb model and the natural language processing and lexicon-based text mining methods and opinion mining workflows. While all of these methods have some promising results, they also have certain limitations that has been mentioned in here, like insufficient training data performance that can be improved performance for accuracy and F1 scores. So overall, the existing research highlight the importance of the sentiment analysis, but also indicate a clear research gap in terms of accuracy, scalability, and practical applicability. This gap motivated us to propose our approach for more effective sentiment analysis in marketing context. So this is our problem statement. The work addressed the problem of automatically classifying the customer sentiment using NLP techniques. This would be the proposed system. We would be using NLP method to understand the review text and determine its sentiment. The system include the data pre-processing, POS tag and lemmatization, sentiment scoring, classifying the data, determining it is positive, negative, or neutral. Then evaluating the model performance, and insight help marketing teams to identify the customer preference and improvement areas. This is our architecture diagram where we are feeding the data set. We are downloading the data set from Amazon. It is a real data set of video game category. Then we are loading the data set, which is in the TSV format, and we are doing all the cleanings and transforming it into CSV format and further using it. Then the text pre-processing is done. Then sentiment scoring uses the Senti WordNet. Then the sentiment classification, and we are using the ground truth level to evaluate the model. This is the model evaluation using confusion matrix, then the visualization using heat map and reports, then the decision support for business insights. This is the data set we have used. As I have talked in the earlier slides as well, we are using the Amazon data video game data set. We have downloaded it from the AWS site. It was in the .tsv format, and we have converted into CSV for further analysis. After removing all the null values and missing fields, it contains around 144,000 customer reviews. Each of the review has some around 15 attributes, but we took only 4 into consideration. That is customer ID, product ID, star rating, and review text. After cleaning the data, we started exploring the data with some visualization technique that is available in the Seaborn library of Python. During the visualization, we found that most of the review text are positive. So it could create a biasness towards the positive sentiment. So that is why we did random sampling of the data. That means we took 1,500 samples of rating 1 and 5. And for 2, 3, and 4, we took 500 review each. This is our algorithm. After removing all the null values, we did the normalization. Like we change all the tokens into lowercase and remove all the HTML tags and any new line breaks. After that, we did the tokenization of the sentence. Tokenization is basically a process where we are splitting the data sentence into different the smallest unit, which is called as token, which more commonly called as a word. In the NLTK library, we have found a number of tokenization technique like tree bank tokenization and casual tokenization, but we moved forward with the tree bank tokenization instead of casual tokenization. It is because in casual tokenization, most of the it is tokenizing based on the it is tokenizing, but it is not following any grammatical rules that is being followed in the tree bank tokenization. It is actually not considering the punctuation mark, and it is splitting while splitting the word. Casual tokenization are more important in the informal text like social media post or any comments, but tree bank tokenization are for more formal text. So that is why we moved forward with the tree bank tokenization. Then after that, we did the stemming and lemmatization, and we compared both and found that lemmatization is better over stemming. Lemmatization is basically a process where we are converting the word to its base form with a proper grammatical meaning. During the process of lemmatization, we traverse each of the tokens, and while traversing, we have added the POS tags to each of the tokens. That means the part of speech tagging. This is basic. This is very much important whenever, because we need to know the in which context that particular word has been used in the sentence to understand its meaning. After the POS tagging is done, then we convert that word to the WordNet tag so that we can search the meaning of that word in the WordNet dictionary. WordNet is basically a lexical database of English language, which consists of all the meaning of the word. Instead of the traditional dictionary where we all have the words in the WordNet dictionary, we have the meanings. That is basically all the words which have a common meaning are grouped together, and it is called as synset. So based on that, we searched the word and we got the meaning of that particular word based on the tags. Like for example, if it is the word is a noun, then we would have got the meaning based on the noun for that particular sentence. Then after that, we have used Senti WordNet, which is an extension of WordNet library, which actually provide us the score for the particular word, if it is positive score or negative score. Then we have calculated the sentiment behind that particular word with the help of the difference between the positive score and the negative score. If it is less than 0, then it is a negative one. If it is 0, it is a neutral. And if it is greater than 0, then it is a positive score. Similarly, we have found it for all the sentence, because a review text might contain multiple sentences. So we have broken down that part, and for each sentence we calculated and then aggregated and calculated the percentage. Then for each review text, we have noted down the sentiment score. So this is what we have done. And this is the right hand side image is the snapshot of the code that we are doing. For evaluation, the predicted sentiment is stored in the review sentiment. For any to evaluate the performance of the model, we required a ground truth level. For that, we have considered the review overall ratings, which is in the form of 1 to 5, but our sentiment was in the form of negative, neutral, and 0. So we did a mapping that is 1 to 2 is a negative, that is class 0. 3 is neutral, which is class 1. 4 to 5 is positive, which is class 2. The model prediction are evaluated against the ground truth sentiment level, and the performance is analyzed with the help of a confusion matrix and the standard classification matrix. So this is the result that has been obtained from the model. This is a confusion matrix which can be visualized with the help of a heat map. Heat map basically improve the visualization with the color coding. If the color is more darker, it highlights the higher number of samples than that of the lighter colors. The diagonal of this confusion matrix states the correct prediction of the model, and the off diagonal at the miscalculation predicted by the model. The accuracy can be calculated by considering the correct prediction of the model, which is around 56%. And we can so accuracy is actually not enough for this kind of calculation because it consists of unstructured data set. So we would be calculating the recall, precision, and F1 score for each of the class 0, class 1, and class 2, where class 0 indicates the negative sentiment, class 1 indicates the neutral, and class 2 the positive. So we will be calculating it for the positive sentiment primarily. The recall can be calculated as the true positive and true positive divided by the true positive plus false negative, which is 2433 is the correct prediction done by the model, and 85 and 54 are wrongly predicted by the model. So we can calculate the recall by that. And similarly, precision and F1 score. So the F1 score found out to be 0.6931. This is all about our project work. And we concluded that we have successfully implemented three-class sentiment analysis pipeline, converted the star rating into the sentiment categories, evaluated the model performance using a confusion matrix. Model shows strong ability to identify the positive sentiment, provide a solid baseline for a future sentiment analysis improvement. In a future work, the integration of deep learning model to further enhance the classification accuracy, detecting and filtering of fake spam reviews, extension of the system to multilingual and dominant independent sentiment analysis. These are the few references that we have used. And yeah, thank you.
Okay, am I audible?
Yes, sir.
Okay, which data source you use? Or you or taken social media survey or any reviews, or it is the hybrid
It is a social media review. Sorry, it was from the Amazon review, which is the video game from the video game category.
only? Okay. So, is there any noisy or informal text have you handled for that?
Like we have removed, or if we found any of the noisy data, we have just removed that. And if it is a punctuation mark or something is there, then we have handled that in the code as well. If it contains some new new
Okay.
lines or something like that, then we have handled it in the code.
And how you address the multilingual? Because nowadays, so many multilingual content like emoji, sarcasm. So how you address that?
With the help of the casual tokenization, because in the casual tokenization, actually, it is also handling the emotional polarity of that particular emoji also, but it was not actually giving a proper result because it was not handling the punctuation mark. So that is why we took tree-bank tokenization instead of casual tokenization, because most of it is not like most of the text consists of is more grammatically accurate, but in casual tokenization, it was not considering the grammatical sense of that particular word.
Okay, okay. Nice work. Keep it continue. Thank you.
Thank you, sir.
Thank you. Moving on to our next presentation. We have author Nikunj Kadu with their paper title, The Evolution of Real-Time Collaborative AI Workspace.
Hello, am I audible?
Yes.
Yeah, thank you. Yeah, so good evening, sir. Good evening, everyone. I will be presenting our paper titled The Evolution of Real-Time Collaborative AI Workspace. I am Nikunj Kadu from Pune Institute of Computer Technology. So this paper looks at how research on human AI collaboration has evolved over time. And importantly, why actual or true collaboration between humans and AI is a little bit difficult to achieve despite this rapid progression of AI capabilities. So the motivation for this research is that human AI collaboration is envisioned as a way to form teams that can achieve outcomes beyond what humans or artificial intelligence can accomplish. So traditionally, AI was mainly used as a tool for automation or like doing repetitive or well-defined tasks. But more importantly, like recently, AI has been positioned as an active participant in human work. So this shift has led to an emergence of what we can say is real-time collaborative AI workspaces, where humans and AI interact synchronously within digital environments. So such workspaces have been explored like to diverse domains such as creative working, software engineering teams, companies, cybersecurity, scientific discoveries, etc. etc. Uh, Also, is central problem. So the empirical research which we have done in this paper shows that although AI often improves performance, but the true AI synergy is rarely achieved in practice. We went through a lot of existing works where there was a lot of meta-analysis of over hundreds of studies distinguishing between the human augmentation and AI synergy. And uh, what we lead to a conclusion that uh, stronger evidence for the augmentation, but limited evidence for the AI human synergy was found. So in many cases that a, this AI human teams were performing worse than the individual agent or individual collaboration between humans, which highlighted a mismatch between like what we expected and what we observed. So, like while AI often improves human performance, like human AI teams frequently fail to outperform the best individual agents, like either the human or the AI. So, like in some cases, collaboration even makes performance worse. Like there are many results which I will put forward in the next slide also. So initially, what we did in the literature survey was finding out the early research in this field. So, in this, like early research was largely focused on improving algorithmic performance and was more uh, was more based on accuracy, efficiency, and autonomy, which is what we are seeing right now in the current AI scenario around us. So the idea was that better AI would naturally collaborate better with humans. But with the research which we and the recent studies emphasize the role of human-centered factors such as trust, calibration, autonomy, reservation, transparency, and quality of communication is determining the collaboration success. So it's not all about those metrics or the terms and the tests which most of the AI models are going through. It's a more in depth and depending on uh, different human factors, emotional factors, and mental factors, such as this trust, autonomy, preservation, transparency, as well as the quality of communication with each of the AI. So, so as a result, the focus shifted towards a human-centered factor, which with these all factors which I have mentioned, which marked from an change or a transition from algorithmic centric view to a human centric view for collaborative AI. So let's get to the actual topic, like actual work. So real-time collaborative AI workspaces are like shared digital environments where human and AI, humans, various humans, and AI, like a group of humans and AI work together at the same time. Like unlike traditional AI tools that operate independently or asynchronously, AI in these systems is embedded directly into ongoing human collaborations. So the key point is that success in these environments depends just like not just on what the AI can do, but how well human and AI contributions are coordinated in real time. So the effectiveness, as mentioned, that effectiveness of these environments depends not on only on the AI capability, but also a shared shared context between uh, what humans are discussing, as well as what the AI understands or has the uh, previous context of. So let's go towards the methodological approach for the survey which we took. So this survey analyzes research on the real-time collaborative AI workspaces through different lenses. Uh, we organized the literature in this manner, which reflects the natural evolution of this field over time. So this approach, what we took, uh, allowed us to identify how research prioritizes, uh, like how research priorities have shifted from understanding basic challenges to designing and validating real systems. So by focusing on this progression, our survey highlighted some limitations that persisted across different application areas. And this perspective actually provided a structured foundation for identifying both a few technological as well as conceptual gaps in how the current AI human collaboration is ongoing. So moving forward to the foundational work which we did. So the first phases consists of like some surveys, systematic reviews, and meta-analysis. And these studies map the research landscape and quantified the collaboration outcomes. So systematic reviews move beyond categorization by synthesizing findings across multiple studies to provide evidence-based insights. Like there were various major meta-analysis combining results from like over 100 experiments, distinguishing human augmentation and synergy, as I mentioned already earlier. Uh, so while the augmentation is consistently observed, true synergy is lacked. So, and especially in tasks which are creative and where our humans outperform very well. Let's go to the
Sorry to
conceptual.
interrupt. This
Yeah,
is a gentle reminder that please conclude your presentation in 1 to 2 minutes.
already. Yeah. So these conceptual frameworks led to like this research led to understanding various conceptual frameworks such as the coffee as well as A2C, which is a HCR framework based on automation, uh, collaboration as well as augmentation. This helped to understand the collaboration of AI as well as human in a better way. So there were various empirical findings which consistently showed that overly proactive or autonomous AI behaviors is perceived as intrusive, while constant and adjustable AI's participation supports better collaboration. Finally, from this our research paper, we understood that current research largely focuses on simple human AI dyads, that is one-to-one communication, with limited attention to complex ecosystem. So our paper uh, concludes that future collaborative AI systems must adopt a human in control paradigm, prioritizing interaction designs, transparency, and user agency over autonomous intelligence. Thank you. I am open to your questions.
Okay, Mr. Nikunj.
Yeah.
So, when you are presenting any work, okay, it's better to discuss either in a flow chart or diagram, figure, table. So it's easy to, it look like attractive and easy to understand for any evaluator. Anyways, um, how your data privacy preserved because sometimes sensitive data we need to proceed. So how you preserve that privacy of the data?
Yeah. So in AI collaborative workspaces, as these LLM models are actually uh, prioritized and they are closed source, most of them. So the data handling part is based on their platforms. Also, if we want to incorporate a data validation or data security from our end, what we can do is storing the chats or whatever the conversation happened between the AI uh, as well as the group collaboration team uh, should be encrypted initially and stored in the database so that privacy remains. Yeah.
Okay. And how your system can manage any, because sometimes multiple user entry will occur. So conflict definitely will arise. So how
Yeah.
can you manage the AI agent and the multiple user conflict input?
Yeah, so there are multiple approaches to it. First, there can be that AI will be manually intervened. That might be a one approach where we ourselves like stop or tell where an AI could intervene. Also, there can be various ways that after a certain point or certain time, the AI will understand the context of the overall conversation and then put forward and give a conclusion. That might be another way. Also, for the complexity which you mentioned, like different AI agents as well as different humans, for that, what we can do is creating an orchestration or a middleware so that it communicates to different agents and creates an abstraction layer uh, so that it can communicate with different AI agents based on their payload or based on their response or request and uh, understand each of the humans' interactions clearly.
Okay.
Yeah.
Okay, nice. Continue your work.
Yes. Thank you.
Thank you. With this, we have come to an end of today's presentations. I sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to host you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. I also thank our session chair, Dr. Ashish Patel. Thank you, sir. A token of appreciation to the chair on behalf of Team ICTCS 2025 and Global Knowledge Research Foundation and partners. Thank you, sir. Would you please like to address our panel with
Thank
your
you,
wisdom?
Meghna. Uh, thank you, ICTCS, Dr. Amit, Richa, for invitation as I am doing. I've done so many evaluation till today, and it was in each and every conference. Always participants presented their work. Very good, good research, ongoing, completed, and definitely good productive outcome will come from their work. So the main concern from my side is when you are doing any research, please convert into the patent or good impact publication. Do not make it like in form of thesis, so there is no use at all. Okay, so wish you all the best for your future journey and progress in your life. Thank you once again, GR Foundation and all the committee members. Have a nice day.
Thank you, sir. Now I kindly request you all to switch on the camera for a screenshot of this presentation. Kindly please switch on the camera. I request all the participants to kindly please switch on their cameras. Thank you, everyone. Thank you for joining and your participation. Thank you, sir.
Thank you.